guys, hope you are doing well. So let's study about eigenvalues once again. That is, let's try to solve another problem based on eigenvalue. So let's take a matrix. Matrix A is equal to 2, 1, 1, 1, 2, 1, 0, 0, 1. So this is the matrix. Let's try to find out the eigenvalues of this matrix. So I hope you all know, you have all seen the previous video, that to find out the eigenvalues we have to take use of this characteristic equation. Characteristic equation is nothing but a minus lambda I determinant, which is equal to 0. So let's write a minus lambda I. A is nothing but 2 minus, I'm just writing directly, lambda I. I is nothing but identity matrix of order 3, because the order of the matrix that is given is 3. So we have to take the order of I as 3. That is 2 minus lambda and 1, 1 as it is. Here also 1. Here 2 minus lambda and here also 1 as it is. Here 0, 0. Here 1 we have to write it as 1 minus lambda. So this is the characteristic equation we got, which is equal to 0. So let's try to solve the determinant. So to solve the determinant, generally we do that. We take the first row and put the sign, that is alternative plus and minus signs, plus, minus, plus 2, the 3 elements. But here there is a catch. Just let's observe this determinant, that in the last row we have two zeros as elements. So if we consider the last row, it's very easy for us to solve this determinant, because if we take alternative plus and minus in the last row, we have to only deal with the last element, because 0 into anything is 0. So we have to deal only with the last element. So this makes easy. Let's write 1 minus lambda into neglect this column and this row. We remain with 2 minus lambda into 2 minus lambda, that is 2 minus lambda whole square, minus 1 into 1, that is 1, which is equal to 0. See how simple it is. So just by observing some problems, it's really going to be very easy. So by seeing it, we can say that 1 minus lambda is equal to 0 and 2 minus lambda whole square minus 1 is equal to 0. This is one factor and this is another factor, so we can equate it to 0. Here we have lambda is equal to 1. This is one of the eigenvalues, so we got it. Very simple. And let's solve this. 2 minus lambda whole square is equal to 1, and by square rooting on both sides we'll get 2 minus lambda is equal to, we have plus or minus 1, because when we take square roots on both sides we have to take plus or minus. So let's write once again, that is 2 minus lambda is equal to, let's take plus 1, and 2 minus lambda is equal to minus 1. We have two factors. One is for plus 1 and another one is for minus 1. So minus 1 is equal to 1 minus 2, and we'll get minus lambda is equal to 1 minus 2, and minus lambda is equal to minus 1. So lambda is equal to 1. This is one of the eigenvalue. And let's solve this. Minus lambda is equal to minus 1 minus 2 minus lambda is equal to minus 3. So lambda is equal to 3. So this is one of the eigenvalues. So these are the 3 eigenvalues that we got. That is lambda is equal to 1, 1, 3. So these are the 3 eigenvalues of this vector. Very simple, very convenient. So thank you so much for watching the video. Happy learning.